Mr. Pavan Surana. Mr. Pavan Surana is the promoter
Yes.
of Coolmax Enterprises. For more than a decade, he has been associated with the company. He has industry experience in dealing with fluorochemicals used in ACs, refrigerators, and car ACs. Mr. Pavan, AGMP from IIM Ahmedabad, has contributed to the development of R22 for around a decade with a large customer base. He is leading wholesaler in South India. Today, Mr. Surana will walk us through knowing about GWP and few ways to reduce GWP in long run. Welcome, Mr. Surana.
So I'll tell about the advancements in low GWP and also to reduce how we can reduce the GWP. Some ways, some things which we can do as common man. So GWP, I'll be very fast with this presentation. It's GWP is global warming potential. How long the refrigerant remains active in the atmosphere, because the refrigerant ideally should not be active in the atmosphere. If it is stable, then it's not good refrigerant. It should become unstable very quickly. So the existing refrigerants you already know, 22 HCFC, and you have HFCs like 134A, 407, 404, etc. So this slide has already been covered by one more person, one more panelist. Science has come a full circle. Earlier there was hydrocarbon. Again, people are coming back to hydrocarbon and natural refrigerants. Science has done progress, but in a way, it's an irony. Maybe some progress has not been done somewhere. So this is the HFC phase down. 85% reduction will be done in 2047. Only this point to remember. And remaining things you have it in Google. So the future refrigerants. What are the future refrigerants? We have one future refrigerant which is hydrocarbon. It is having GWP which is negligible, ozone depletion 0. So why don't we use it? And why it is not a perfect refrigerant? Because GWP is negligible. ODP is ozone depletion is 0. The reason for this is it is highly flammable. Practically, this is not possible, to store it in large containers inside the city. Because if you store all refrigerants outside the city, many people cannot participate. There will be only like few dealers or importers who will be selling the refrigerant. Because in a city like Chennai, there are 300 shops. All 300 shops cannot be outside the city. Maybe in future it might be possible. But what generally happens is there are shops which are in some areas, you'll have some shops. Again, some areas you'll have some shops, some few more shops. So this is what happens practically. So hydrocarbon, actually people are storing, but actually it's, ideally it's not that good because they can catch fire. They are highly flammable. And the permission for that is around 5 kgs. But people stock, 1000 kgs also, 500 kgs also. They are violating the rules. But this is what is happening in a country like India. So what is the solution to this problem? Which, hydrocarbon is a good refrigerant, but what is the solution to the problem of flammability? HFOs. HFOs are mildly flammable. Now, there is a lot of difference between highly flammable and mildly flammable, because when it is mildly flammable, the chances of flammability gets reduced very much. It is much safer, but not completely safe, but it is much safer. So you have HFOs like 1234YF. HFOs are having 0 ozone depletion and very low GWP. It's like 4. It's used in car ACs in Europe, and India also exports some cars. Many countries in that also they are putting HFO 1234Y. So why this is not immediately used instead of HFC like 134A? That's a question which anybody should have asked me. Why not? Why not immediately replace it? You have refrigerant is ready, everything is fine. Why it's not happening? So, but in Europe it is happening. We have F-gas regulation as already discussed. So I'll not discuss much about this. The properties of HFO is that they are stable in the system. This is very important. They are not stable in the atmosphere. GWP is less when they are not stable. It is efficient. So I got many questions like why oxygen is not used, why this is not used. The refrigerant has to be efficient first of all. If you see R32, it is an efficient refrigerant. That is why they have come up with R32. Just not like that, just like that they have not developed R32. R32 is even more efficient than other refrigerants. Like for example, you have 22 gas. It is more efficient. You get more cooling performance. The energy consumption is less. So if you use just like that any refrigerant, the energy consumption may go up. As already discussed, the indirect impact. So that indirect impact will be reduced when you use HFO. Now, balance is needed in refrigerants. It's very important. So these 4 points, when it comes all together, then only you can have a refrigerant, not like only 0 ODP, 0 GWP, and we are done. No, it's not like that. It should be energy efficient, should have cooling capacity. No cooling comes, no use. And the cost of the maintenance has to be less. An initial cost must be less. So all four has to be satisfied 100%. So these are the replacements of HFCs. Suppose you take 22 gas, which is having 1810 GWP. There is a gas called XL20, okay, by some company. They have manufactured it, which is having which is mildly flammable, having a GWP of 148. It's available, but the problem with this, it is costly. It's not available properly. That's it. But the refrigerants are ready. If you have 134A, you have 1234. Refrigerant is ready, and people have started using it. But you will come to know why they are not using. So 404 has XL40. You can change the system and you can use XL40 very easily. But the system has to be changed, and the refrigerant is a bit costly. That's the only problem. That's why people are continuing with this. They want cheap refrigerant. In a country like India, even 5 rupees matters. Let me tell you. But these refrigerants are, sometimes 1234 is 10,000 rupees per kg. Nobody is going to buy that, because what happens in India is, practically in a forum like this, there are, duplicates of refrigerants. I would like to say, if you have 22, there will be a duplicate for 5 rupees, 10 rupees, 50 rupees. People go to duplicate refrigerants. Do you think they will use 1234? No. This is one big problem. Even 134, people are using R12 still in the R12 car ACs. So instead of R12, they are using 134A. Instead of 134A, earlier 12 was used. So all these things, gimmicks will be done in a country like India. And that is also a little bit of concern. Now, how do we reduce GWP? How can we do as a common man? See, the policy has to be changed by Government of India. Why wait for 2047? The people can address to government. And like I have also tried it in several other issues, not this issue, and we can change the policy of the government in other countries. Our government can ask other countries as well. Why wait for 2047 for the HFOs or whatever it is? It can be accelerated by some amount of time, maybe 10 years, maybe 5 years, maybe 15 years. And next, the second important thing to reduce GWP, what we can do is don't use spurious refrigerants. For example, you have 404, which is having 4,000 GDP or around that, 3009 and something. People are using 404 instead of, when it was cheap, then they would use it. Instead of 22, they will use 404 when 404 was rupees 250 per kg. So these things, when they do, they'll damage the compressor, they'll consume more energy, and there will be many problems. And indirectly, they are contributing to the GWP. We can use new technology, R32 air conditioners. R32 is having 600 GWP. If you go for 22 air conditioners, you'll be, 3 times it will be. So avoid, R22 ACs or R410 also, for that matter. You can go with R32, which is presently ready in the market. What is there with us, we can do that. What is there in our hand? Because what is not there in our hand, we cannot do. So next, we also have this hydrocarbons in refrigerators. Company like Godrej is promoting this hydrocarbon-based refrigerators. It is having negligible GWP. And also we can try HFOs in new systems, which the OEMs can do. Next, there is also one more thing, like for example, shift to retrofit refrigerants having lower GWP, because our 404 existing systems, if they use XL40 with some modifications, it can be done. And people have explained this, and it can be done. We can avoid 404 in many new projects, many big projects. We can avoid this, and you can use XL40. You can contact the concerned importer. They will provide you the refrigerant. And also, there is one more very, very important point which the trade field people sometimes do, sometimes don't do, is recover the refrigerants from cylinders and systems. Because when you do that, you are contributing to less GWP to the environment. And I also do this in my premises. I try to recover all the refrigerant from the cylinders and from systems. These OEMs also, sometimes we have seen they have recovered the refrigerant and they use it. They don't release the refrigerant in the atmosphere. They give it to some dealer. He will use it for some purpose. But there are problems in HFOs, like they are very costly, as I already discussed this. 1234 is 10,500 per kg. That's why it's not used as of now. Nobody is going to pay 10,500 per kg. Any dealer or any consumer will not be ready for that. Many consumers will not be ready, maybe, because there are people in India who don't understand that GWP concept. There are technicians who don't understand. They understand one thing, which is price. Price has to be less. 1234 is not available easily in India. That is one big problem. Or the HFOs in particular, they are mildly flammable. So storage and transportation will be a problem, because there is some rule in India that you can't keep more than 5 big cylinders in one premise. You can't transport more than 25 big cylinders. So you have to break the rules, which will be a problem actually. So that is one problem with HFOs also, because 22 gas, you can store 200 cylinders. That's it. Nobody is going to question it. without any license. This is one problem with HFOs. The regulations will be not followed properly, and this is one thing which I'm concerned also. Distributors won't be able to have their warehouses inside the city because you will break these rules, and there will be like more than 10 distributors in a city like Chennai. Maybe you'll have 15 in Bombay, big distributors, and everybody cannot have inside the city. That's one problem. And when we don't have inside the city, the transportation is a little tougher. You spend more amount in diesel in transporting the refrigerants. So indirectly, you're again contributing to GW. So this is from my side. Thank you so much.